Welcome. In this video, we'll work through a couple problems that you might expect to encounter when working with the empirical rule, particularly the count by thirds empirical rule. So let's get started. So we'll start with a data set that has weights of a species of bird. The mean of the data is 86 grams, and the standard deviation is 9 grams. The relative histogram is shown to the right. And we'll notice that the average at 86 is indicated in the center of the distribution. So there are two related questions that you might encounter when working with the count by thirds empirical rule. The first question is, in what approximate interval would you find the middlemost 80% of the data? And that number 80% could be changed. Another version of the problem asks something along the lines of, instead of giving a percentage, actually giving the interval and asking what percentage of data might be located there. For example, approximately how much of the data is in the interval 65 grams to 107 grams. To start a problem like this, the first thing that we want to do is not think about whole standard deviations, which is 9 grams in this case, but we want to think about 1/3 of a standard deviation, which is a third of 9 is 3 grams in this context. And what we're going to do is we're going to start at the mean, which is 86, and we're going to count 1/3 of a standard deviation above and below the mean, and then we're going to continue that process to count, quote unquote, by thirds, thus the name count by thirds empirical rule. So 3 grams below 86 is 83, 3 grams above 86 is 89, and that gives us 1/3 of a standard deviation above and below the mean. Continuing, if we go another 1/3 above and below, that takes us down to 80 and up to 92. The count by thirds empirical rule says approximately 50% of the data is found between negative 2/3 and positive 2/3 of a standard deviation of the mean, or 2/3 of a standard deviation below the mean, 2/3 of a standard deviation above. In this context, about 50% of our data should be between 80 and 92 grams. Continuing again, another 1/3 out of the standard deviation captures about 70% of the data. In this case, we would expect 70% of the data to be between 77 grams and 95 grams. Continuing another 1/3, 3 below 77 and 3 above 95, takes us to 74 grams and 98 grams. The count by thirds rule says that if you go 4/3 of a standard deviation above and below the mean, that should capture about 80% of the data. And there is the answer to our first question. In what interval would you find the middlemost 80% of the data for this data set? It would be between 74 and 98 grams. Continuing, if we go another 1/3 of a standard deviation above and below, that takes us to 5/3 of a standard deviation above and below the mean. The count by thirds empirical rule says about 90% of the data is within 5/3 of a standard deviation above and below the mean. The next step, another third standard deviation below and above, so 71 down to 68 and 101 up to 104. That's 6/3 of a standard deviation, which is also 2 whole standard deviations. But 6/3 of a standard deviation captures about 95% of the data. And last but not least, if we go another 1/3 above and below, that gives us 7/3 of a standard deviation below the mean, 7/3 of a standard deviation above the mean, ranging from 65 to 107. And the count by thirds rule says that about 98% of the data falls within 7/3 of a standard deviation above and below the mean. And that answers our second question. Approximately how much of the data is in the interval 65 to 107? In this case, it would be about 98%. Okay, those types of problems work directly calculated using counting by 1/3 and continuing sort of on a scale, thinking about the x-axis as a ruler demarcated by 1/3 of a standard deviation, starting at the mean and going to both to the left and to the right. So here's another type of problem that we might encounter. A data set has the difference in weights between matched pairs of ducks. The mean difference between the male and female weights is 50 grams, and the standard deviation is 15 grams. The relative histogram is shown to the right. Approximately how many pairs have males that are 50 to 75 grams heavier than the matched pair? So to use the count by thirds empirical rule for a problem like this, we're going to focus on both the mean, which is 50, and the value 75, which is the upper range of the interval we're being asked to work with. 75 is 25 grams above 50, and 25 is if we take 25 grams and divide it by the standard deviation of 15 grams, that gives us 5/3 of a standard deviation. We know that if you go 5/3 above the mean, 5/3 below the mean, that captures about 90% of the data. But we're also going to take now advantage of the fact that the normal distribution, or nearly normal distributions, are symmetric about the mean, or very nearly symmetric about the mean. That means if we cut the interval at 50, where the mean is, then we would expect half of 90 to be in the lower half, and the other half of 90 to be in the upper half. So in other words, we find that between 25 to 50, there's about 45% of the data, and from 50 to 75, there's also about 45% of the data. And that gives us the answer we're looking for. Approximately 45% of the pairs have males that are 50 to 75 grams heavier than their matched pair. So in the first example we saw, we were working with very nice numbers that were exactly the same number of standard deviations above as below the mean, and that was the interval. In the problem we just worked, we were working from the mean up to one of those boundary values that's dictated by the count by thirds rule. What happens if we have an interval that is not the same number of standard deviations above and below the mean, or an interval that starts or ends at the mean? So let's work an example that falls into this category. We have a data set with a mean of 50 and a standard deviation of 15. Approximately how much of the data falls between 40 and 75? So the first thing we're going to note is 90% of the data is captured within 5/3 of a standard deviation above and below the mean. A third of 15, the standard deviation is 5. 5/3 then would be 25. So 25 above and below from 50 would take us up to 75 and down to 25. 90% of the data falls within this range. As we saw above, if we split this at the mean, then we get 45% of the data falls from 25 to 50, and the other 45% falls from 50 to 75. Likewise, we know that 2/3 above and below the mean captures about 50% of the data. 2/3 of a standard deviation in this case is 2/3 of 15, or 10, and 10 units above and below 50 takes us from 40 to 60. 40 to 60 would capture about 50% of the data for this data set. That means from 40 to 50, we would capture 25%, half of 50, and from 50 to 60, we would capture the other 25%. Now we're going to focus here on the 25% from 40 to 50 and the 45% from 50 to 75. If we put those together, we see that from 40 to 75, we would capture the sum of 25% and 45%, or about 70% of the data. So 70% of the data falls between 40 and 75. Now, the question is, well, how would you work this if we just had the picture that looked like this, knowing that we're going from 40 to 75? Well, you kind of would work it backwards. You'd start by splitting your interval at the mean. So you want to go from 40 to 50, and then 50 to 75. Then you ask yourself, all right, how far is 40 below the mean? And then I want to look at the comparable region above the mean. That would take me from 40 to 60, and we know that that captures a certain amount of the data. Doing the same thing for the interval from 50 to 75, the mirror side of that would be down to 25, and 25 to 75 captures about 90% of the data. 40 to 60 captures about 50% of the data. So if I were to add these two together and then divide by 2, 50 plus 90 is 140, and divide that by 2, that would give me 70%, which also gives me the same answer as before. All right, let's work a problem that asks for a slightly different type of percentage. Instead of focusing on the middlemost percentages, which are the percentages specifically dictated by the count by thirds rule, let's work a problem where we're looking for a lower or upper percentage. We have a data set of 4-month-old saplings with a mean of 50 and a standard deviation of 15. What is the boundary height for the lowest 10% of the trees in this data set? So I'll just make a sketch here. Now, I actually don't really know where the numbers are just yet, but I know if I'm looking at the lower 10%, I'm going to mentally imagine that there's a comparable upper 10% as well. Because this then allows me to very clearly see that in the middle, I'm looking for the middlemost 80%. And that's what makes these problems a little challenging. If I'm looking for the lowest 10%, I actually need to focus on the middle 80%, because the middle 80% separates the lower 10% from the upper 10%. What I know about the count by thirds empirical rule, 80% is captured by 4/3 of a standard deviation above and below the mean. 4/3 of 15 is 20. 20 below the mean of 50 takes me to 30. 20 up from 50 takes me to 70. So I know between 30 and 70, I capture the middlemost 80% of this data. So this means the lower 10% of the data would be at 30 or below. Now, the flip side of this problem is to ask in the other direction. So this is almost the same problem, but just asked from a slightly different perspective. We have a data set of 4-month-old saplings with a mean of 50 and a standard deviation of 15. What is the boundary height for the tallest 90% of trees in this data set? So here we're looking for the upper 90%. Well, the thing to remember about the upper 90% is the boundary value that separates the upper 90% separates the lower 10% from the upper 90%. And we can now just focus on that lower 10% to answer this question. Again, we automatically imagine that there's a mirror to that because of the symmetry. From the lower 10%, there's a mirror upper 10%. And in between is the middlemost 80% separating those two. Once again, we know that the middlemost 80% is captured within 4/3 of a standard deviation above and below the mean. 4/3 of 15 is 20. 20 above and below 50 takes us to 30 and 70. And if I'm focusing on the lower 10%, the boundary value would be 30. But once again, the lower 10% is separated from the upper 90% by the boundary value 30. And that actually answers the question for us. I hope walking through these demonstrations have proven very useful to you. Good luck.